Well, good day, ladies and gentlemen. Today we're going to talk about the efficiency of an induction motor. So we know that efficiency is the ratio of the output power over the input power. So what we are going to be doing now is checking what's happening between the input and the output. So we are going to check the power flow from input to the output of the induction motor. So to do that, we have to consider the power flow diagram. So the power flow diagram helps us understand what's happening between the input P in and the output P out. So now we're going to start from the beginning. So the input power into an induction motor P in is calculated using the formula root 3 V I cos theta. So this input power is the one that is going to be supplied into the stator of the motor. So after supplying power into the stator of the motor, we're going to experience stator copper losses due to the stator winding. So stator copper losses due to the stator winding. So the stator copper losses is calculated using the formula 3 I squared R stator. So after the output, the input into the stator, we experience the losses, and then we are going to have the air gap power, PAG. So this PAG sometimes is also called stator output. We're going to write it here. Sometimes they say stator output. Sometimes they call it what? Rotor input. So the power comes in to the motor and then goes to the stator, and then we can experience stator losses, and then we have PAG. So PAG, the air gap power, we can say it's P in minus P stator copper losses. And then after that, the PAG is going to be the input power into the rotor. After the power gets into the rotor, we also experience the rotor copper losses due to the rotor winding. Rotor copper losses due to the rotor winding. And that one is called rotor copper losses. And is calculated using the formula IR squared and rotor resistance. We can calculate the rotor current using the formula EMF induced in the rotor over the impedance of the rotor. After the input, after the rotor copper losses, we're gonna have P conv. P conv is also called rotor output. It's also called P induced. So P conv can be calculated using the formula 2 pi nRT over 60. This is the rotor speed and this is the torque. It can also be calculated by saying it's going to be PAG minus rotor copper losses. We get this one. We can also say P conv is equal to PAG minus P rotor copper losses. This is also called the gross output. This is the gross output before we consider the constant losses. So after that, we're going to have the constant losses, which are due to the friction and windage and due to the ion losses. So this is called P friction plus windage, or we can say P constant. So now to get the power output, it's going to be P conv minus P friction plus windage. So now to summarize this is that the input power minus the stator copper losses, we get PAG. PA gap minus P rotor copper losses, we get PConv. PConv minus P friction and windage, we get output power. If we are given the output power, to get the input power, we're gonna say P output plus friction and windage, we get P converted. P converted plus P rotor copper losses, we get P air gap. P air gap plus P stator copper losses, we get the input power. So from input to the output, we are minusing. From output to input, we are going to add the losses. I hope that is clear. So there's another way that there's another table that I use, you can employ to solve this easily. So please copy this table somewhere. So on this table, you can write it like this. Okay, so we're gonna say here we have PAG, and here we have P rotor copper losses, and here we have PConv. I'm gonna put one here and one here. I'm gonna put S and I'm gonna put 1 minus S. So to get rotor copper losses, it's gonna be slip times PAG. So this is slip. I'm sure we know what slip is by now. So if we don't know what slip is, you can just check the link in the description where I teach about the basic induction motor formulas. So to get P converted is gonna be 1 minus slip times PAG. So what does this mean? This means if you can get one power and slip, you can get the rest of the other powers. If you can get P converted, then that means you can get PAG and get P rotor copper losses. If you know P rotor copper losses and you can calculate slip, then you can get the rest of the other powers. Okay, what I might have forgot to add here is that we can also calculate PAG using the synchronous speed. So to calculate PAG using the synchronous speed and torque, you can use the formula 2 pi ns t over 60. See here is 2 pi nr. For this one is nr rotor speed, and for PAG here is gonna be ns, which is synchronous speed. The formula is the same, the only difference is going to be the speed. Torque is going to be the same throughout, because torque is the force that causes rotation in the DC machine. So you must understand that whatever power that you are given in the statement, unless stated otherwise, that's going to be your output power. So now we're gonna go through an example. Just you can pause the screen, read the question, and then you can try to attempt it, and then you can just stand back and start the video again. But you can go ahead now and pause the video after the question has been on the screen. Okay, my babies. Okay, now, so the first question, they've asked us to calculate the torque developed at a slip of 4%. So now to calculate the torque developed, we can use this formula. Either we can use the formula to calculate torque PAG, and then we can calculate torque here, or we can use the formula to get PConv, and then after getting PConv, we can calculate what? The torque here. So now we can also get those powers by using this table here. We have been given slip. So if we can get PAG, that means we can use this formula to calculate what? Torque. If we can get Pconv, then we can use this formula to calculate what? The torque here. But it's usually easy to calculate the rotor copper losses. So after we've calculated the rotor copper losses and we have slip, that means we can get PAG and then use this formula to calculate what? Torque. So now let's just get on. So we have been given okay, I paused the video to quickly write the data that we have been given. So now to calculate the rotor copper losses, you can use this formula here, which is 3IR squared R. I rotor current squared. So to calculate the rotor current, we can use this formula here. So what we have to know here is that when we want to calculate the EMF of the rotor is at standstill, where S is equal to 1, and when the motor is going to okay, now I'll pause the question to so now to calculate IR here, we know that the difference between when the slip is at standstill, S is equal to 1, when the motor is now officially, so when the motor is at standstill, S is equal to 1, but now when the motor starts to move, slip is going to be changed to a certain percentage. So that means the frequency of the rotor is going to change as well. If the frequency change, that means the EMF is going to change. Also, the reactance is going to change. So now when we are calculating, we have to calculate. So our ER1 is moving. Remember that this is a 3-phase, so we are calculating considering the per phase value of the motor. So since this is 3-phase voltage, then we have to divide it by √3 to get the phase voltage. So that one is going to be 220 over √3, gives us 127.017 volts. And then to get our ER when moving, it's gonna be slip times ERO. Say this one is at standstill, so it's gonna be 0. Okay, times 0.04, gonna be 5.081 volts. Similarly to the impedance, now when we want to calculate ZR when the rotor is moving, it's gonna be R plus JS X RO. Remember guys, to put slip when you're calculating the reactance of the motor. So it's gonna be R is 0.25 plus JS 0.04 times XO, it's 1.3. So this gives us 25 plus it's gonna be 0.25 plus J 0.04 times 1.3, it's 0.052. So let's convert this to polar. Okay, I'm gonna put my calculator on complex. If you are using a different calculator, you must just practice how to convert between polar and rectangular. Okay, it's 0.255 angle 11.75. So now to calculate IR is gonna be ER over ZR. Therefore, what did we get here? It's 5.081 angle 0 over 0.255 angle 1.75. This gives you, calculate. So when we divide, gonna be this, divide by this, then this minus that. But if you're using this calculator, you can just substitute and then it will give you the answers. So it's 5.081 angle 0 over 0.255 angle 11.75. This gives us 19.925 angle minus 11.75 amps. So that is the current that is going to be flowing in the rotor. So now to calculate the rotor copper losses that we have, now that we have this, so to calculate P rotor copper losses is gonna be 3 IR squared over RR. Then that means it's gonna be 19.925 squared. What is the rotor resistance? 0.25 ohms. Then this will give us 3. Okay, so this will give us 319.925 squared 0.25. It's 297.754 watts. So this is your rotor copper losses. So now that I have calculated my rotor copper losses, so I can come back to this formula. So according to this table, it tells me that P rotor copper losses is equal to slip times PAG. So remember that I want PAG in order to calculate torque. So to get, now I have this and I have that, that means I can get PAG. Ne? So my rotor copper losses are 297.754 is equal to slip is 0.04 PAG. 0.04, since I want PAG, this will cancel, and then PAG is equal to 297.754 over 0.04. Give me 7443.85 watts. So now I'm coming back to the formula now that I've calculated this. So I got this, and now I need NS in order to calculate what? Torque. NS is the synchronous speed. So I need to calculate the synchronous speed. So the formula to calculate synchronous speed, NS is equal to, NS, it's 60F over P. F is the frequency and P is the pair of poles. So it's gonna be 60, and they said it's a 50 hertz. And how many poles? They said it's a 6 pole, so the pair of poles is going to be 3. So what do we get? $60 times 50 over 3. Get 1000 RPM. And now we come back to our formula. PAG, it's equal to 2 pi NST over 60. So PHG is what? It's 7443,85 is equal to 2 pi 1000 T over 60. So now I can calculate for T. I'll cross multiply this and then I divide. Therefore, T is equal to 7443,85 times 60 all over 2 pi 1000. What do you get? Equal to 71,084 Newton meter. Okay, I hope that you learned something here, but now we are going to continue. Now we are going to calculate what? We are going to calculate, and we are going to go to the second question, which is asking us to calculate what? The power input if the stator losses are 450. So now to get the stator input, we have PAG, and they gave us the stator rotor. Now we have PAG, and they want us to calculate the input power. So which means PAG plus this gives us that. Remember, when we are going this side we are adding, and when we are going that side we are going to be minusing. So they want us to calculate the input power. So it's going to be PAG, which we already calculated, plus this which they gave us. It's going to give us what? Our input power. So let's do that in writing. So now the P input is going to be PAG plus P stator copper losses. So what did we get? What is PAG? PAG is 7443,85 plus what is our rotor stator copper losses? It's 450. So this is going to give us 7443,85 plus 450. This gives us 7893,85 watts. So that was question 2, to calculate the input power. So now the third question asks us to calculate the efficiency of the motor if the friction and windage is 230. So now we have to calculate what? Now we have to calculate the efficiency. So to calculate the efficiency, we're gonna need to calculate the output power. We already have the input power. We have this. We don't have this, but we can calculate what? The output power. And after calculating the output power, then we'll be able to calculate the efficiency. So now let's calculate. Okay. Okay, now they gave us the friction and windage, and we have to calculate the output power. So to calculate the output power now, since we have PAG and this minus this is going to give us this, and this minus this is going to give us that. So we can also just say this minus this and this gives us that one. I think that will be the easiest way to do it. So to calculate the output power is going to be PAG minus P rotor copper losses minus P friction plus windage. So PHG is 7443,85 minus the P rotocopper losses. My rotocopper losses is 297,754, and friction and windage, they said friction and windage is 230 minus 230. So what does this one gives? So output power is 6916,096 watts. Then to get the efficiency, it's gonna be P out over P in times 100. This is gonna be 6916,096 all over. What's our input power? We have calculated that one. Where did we calculate our input power? Okay, our input power was 87,893,85 times 100. So this gives us 6916.096 over 7893,89 times 100. So this gives us 87.614%. Okay, that's it for today. As you can see, in my calculation from the beginning, I've been putting all of my answers in once. So for more accuracy, you can just put your answers in kilowatts. I think that is more accurate than putting all your answers in these full numbers. Yeah? But anyway, I hope that you have learned something. So I'm just going to go on and do some another questions. But for now, please don't forget to subscribe and hit the bell icon so you can learn some more about induction motors and all electrical equations and questions that you have. So please leave a questions below so that I can get back to you. Yabona mos. Sure.